Free Energy Basics Engineering Design Process. Instructor Ryan Anderson. You might think there's only one engineering design process, but the reality is everyone uses a slightly different process, and that's okay because it allows for adaptability. These examples for different grade levels from NASA are suggested steps. You will find that once you begin working with the design process, it becomes less linear and more fluid. Identify the problem. Step 1. At Fabulous Resources for Energy Education, our wind turbine hubs used too many parts and were complicated to construct. We needed a solution to simplify the kits and make them more user-friendly for students. Step 2. Identify the criteria and constraints. Criteria. The hub needs to hold a pinwheel and 2 to 6 custom propeller blades. The hub must fit the existing motor shafts of 2 mm and axles of 1/8 inch. The hub needs to be proportional in size to the current wind kits. Constraints. The new hub must be safe. Students will be using the hub. The hub needs to be simple and easy to use. The final project needs to be mass-produced at a low cost. Step 3. Brainstorm possible solutions. We researched what was currently available on the market. Most hubs were too large and only fit one set of blades, or would not fit the shaft and axle size necessary. Step 3 continued. We began brainstorming with materials we had easy access to, including plastic caps, cardboard, corrugated plastic, and wood. We continued by brainstorming with possible design elements, including interference fit, screw together, and disposable versus reusable parts. Step 4. Generate ideas. After brainstorming, we created 3 possible hub designs: the disc hub, the wheel hub, and the double-sided hub. Step 5. We combine this step with the next step, select an approach. This is an example of how you adapt the engineering design process to your needs. Step 6. Select an approach. Using a decision matrix, we evaluated the advantages and disadvantages of each idea. Originally, we chose the double-sided hub. This design could be used for the axle and shaft, as well as the pinwheel and the propeller blades. As you can see from the design matrix below, we chose the double-sided hub as our winner. Step 7. Build a model or prototype. After selecting a solution, 3D modeling software was used to turn the sketches into a model. Let's go to the UNI Industrial Technology Center and I'll show you how we did this. Once we finished our design process and came up with the final hub design, we took it to 3D modeling software. This is our model that we landed on for our hub design. Once your 3D CAD model is complete, you will save the model as an STL. An STL file renders the surfaces of your model as triangles. The 3D printer will then use these coordinates to produce the 3D object. On this software, it'll tell us the size of our part, and so I'm just going to adjust the scale until I know it's the right size that we dimensioned it to in our 3D modeling software. And then we can arrange them on the tray how we would like them to print. Before we go any further, I'll explain really quick what support and model material are. Here's an example of a hub I printed earlier. The yellow material here is what's known as model material, and this sort of brown, blackish material is known as support. Because a 3D printer works by building a part layer by layer, it needs to have support in certain parts in order to hold up the top layers from falling down while it's cooling. Alright, now that we have finished building our tool paths on the computer, we've sent the part file to the 3D printer, and the 3D printer will tell us if we're ready to start. It should take about an hour and 2 minutes. Alright, once the 3D printer has finished manufacturing the parts and it's cooled, we can take them out. All we have to do is move a couple pins and slide the tray off, and then the finished part comes out stuck to the tray. So once we've removed our parts from the 3D printer, the tray will look like this, and then the parts usually are still stuck to it because of the heat. But after it's cooled, all we need to do is we can kind of twist, and the tray won't break usually, and we can pop these off. Okay, once all the parts are removed, we can set our tray off to the side. Now, these parts here still have the support material on here like we discussed earlier. We're going to toss these into a metal basket that we're going to put into the parts cleaner. So before we put our parts in the cleaner, we want to make sure we're safe while we're operating this equipment. So we're going to put on safety glasses, an apron, a mask or a shield, and some gloves. Then we can come over to the machine, open up the top. And all we have to do is place our parts that are in our wire container into the tank. Once the parts basket is placed in the parts cleaner, we can set the cleaner to run for 6 hours. After 6 hours, we can return to the cleaner and remove the parts basket. We'll then rinse the parts and soak them for an hour before using them with students. Once they are done soaking, the parts are ready for use. Step 8. Refine the design. We continued by testing the prototype with our current wing kits, using the different size shaft and axle as well as multiple propeller blade styles. After testing, we decided to use 2 hubs in order to simplify the part. We continued by testing new prototypes and making design changes until our problem was solved and our constraints and criteria were met. This is an example of another adaptation of the engineering design process, as shown in the diagram to the right. We used the build, test and evaluate, and redesign loop several times. Current design. Once we developed a design that solved our problem, we began producing the hub with the UNI Department of Technology 3D printer. This provides a short-term manufacturing solution and is allowing us to test the new hubs with the students. These pictures show our current design. What about presenting results? The more complex engineering design process omitted one of the important components of the engineering design process. It's there in the simpler model. Present results. It's critical to share with others the insights you have learned. This is how science has advanced. Assignment. Take the quiz to evaluate what you learned from this video. Continue on to the next lesson. Special thanks to Jay Heilman and the faculty and staff of the UNI Industrial Technology Department.